Hello everyone. Today let's solve the problem number 215, kth largest element in an array. So we have already solved the kth largest element in a stream. We had made use of the minimum priority queue, I think. So based on the requirements, we had solved kth largest element in a stream recently. So now we'll be solving the kth largest element in an array, right? So you can just go through the question and you can just try to understand the question with the help of the examples that they have given, right? So I'll just summarize the question so that it will be easier to understand. Here we are given an integer array nums. We can clearly see here we are given an integer array nums and an integer k, right? And an integer k. You can clearly see here. What is our main task then? Our main task is to return the kth largest element in the array. Kth largest element we have to return in the array. Means suppose the first here you can clearly see the largest element is 6 here. So k they have given 2, nothing but the second largest element. And the second largest element here you can clearly see by looking at the array. We can see here, we can say that 5 is the second largest element. So output has to be 5 in this case. Let's move on to the example 2. Here you can clearly see k they have given 4 in this case. 6, 5, 4, 3. 3 is the fourth largest element in this array, right? So 3 or 4 here in this case. 6, 5. Just give me a second here. 5 we have this one, right? So we have the duplicate number here. So the output will be in this case 4, not the 3 here. In this case 6554 we have, right? So the output will be 4 in this case. So I hope the question is completely clear. Let's discuss the approach first and then dry run this one. Any example 1 or example 2. Let's dry run. Let's take this example itself, first example, and then finally write the edge cases followed by the code, and finally discuss the complexities of the code that we have written. Initially, let's go with the approach as usual. Here, let's discuss the approach step by step. We'll be making use of the max heap. Just remember, we'll be making use of the max heap here. So, why we'll be making use of the max heap? Because maximum element always stays at the top while we make use of the max heap. That we know. That is the reason we'll be making use of the max heap. Instead of sorting the entire array, we can make use of the max heap. So let's see what are the steps to solve the problem. So first what we'll be doing here, let's convert the array into max heap. So just give me a second here. First step is convert array into max heap. So this is what we'll be doing in the first step. What will be the second step then? Second step is extract the largest element k minus 1 times. So we have to make use of the function extract or the method extract, right, while building the max heap. So we will be extracting the largest element k minus 1 times here. So this will be the second step. So third step is return the top element. So we will just return the top element. So as we are going with this in second step, we are extracting the largest element k minus 1 times. We can just return the top element, right? So which is now the kth largest element. I hope this is completely clear. This is the approach that we'll be going with. So let's do one thing. Let's discuss this one with the example. First example that they have mentioned in the problem, right? So let's consider here. Let me do one thing. Let me give you an example. Let's die run this one. So here this will be, just give me a second. They have given here 3, 2, 1, 5, 6, 4. That's what they have given in the example. So output they have given here as this one is 5. We know this one. Let's dry run this one. We'll get to know the approach, right? So accordingly with the approach, let's dry run the code. Let's dry run the example. So here they have given k equals 2. for this one, right? So we need to find the second largest element in the array. So first step is we have to convert array into max heap. So according to the approach, we have to convert. So here is the approach. We have to convert the array to the into max heap. Max heap, why? Because it ensures that the largest element is always at the top. So just let's create the max heap. To create the max heap, let's sort the array in the descending order. And one more thing, they have asked in the question, can we solve this one without sorting? Yes, we can solve this one using the heap itself without sorting, but we'll be making use of the sorting because n log n for this problem is not bad actually. We can just solve using sorting itself, because n log n for this particular problem, it's not bad basically, right? So let's make use of the sorting instead, right? Unnecessary, we have to go with longer steps. Rather than that one, we'll be making use of the sorting. So to mixture of max heap and sorting, we'll go with max heap and sorting, right? To create the max heap, we sort the array in descending order. So this becomes initially the array becomes, after sorting in the descending order, the array becomes now 6, 5, 4, 3, 2, 1. So after sorting, now the largest element is 6, which is at the top in the max heap, right? So this one I'm speaking of 6. So this is step 1. So what will be the step 2 here? Let's move on with the step 2. Now we have to extract the maximum, nothing but k minus 1 times in the approach. That's what we have written here, right? Extract largest element k minus 1 times. So we need to find the second largest element. So we have to remove the largest ones, nothing but in this case k minus 1, that is nothing but 2 minus 1, which is 1 time, right? First extraction, we have to remove the top element 6 from the heap. This is at the top now in the max heap. In the heap, this is the top element 6. When we remove 6 from the heap, this becomes 5, 4, 3, 2, 1, right? So remaining heap will be this one. So next, let's move on with the step 3. So now we have 5, 4, 3, 2, 1 in the heap. So next step is here, while discussing the approach, third step is return the top element, nothing but the kth largest. So now the top element is 5. We have 5, 4, 3, 2, 1 now. So now the kth element is the second largest, right? So now the top element 5 is the second largest in the original array. So now we will be returning 5. This will be the output in our case. So I hope the example is completely clear. This example is completely clear. So and also approach and the example is completely clear. So let's discuss edge cases one by one now. So the first edge case, let's consider smallest input case here. I'll just go with smallest input case, the first input. So here the first case, sorry. So I'll just consider here nums 1 and k equals 1. So the output will be 1 itself, because we have only one element, k is also 1. So the output will be 1. This is for the condition smallest input case. Next, let's discuss with this one. Let's move on with the second edge case, nothing but all elements are same. Let's discuss here all elements are same. When I say all elements are same, let's consider here nums equals, all the elements have to be same here, right? So k equals 2, this has to be, and the output will be 5 in this case. This is fine. This is for the second edge case, nothing but for the condition all elements are same. Now let's move on with the third edge case, nothing but k is the last element. So here k is the last element. This is for the third edge case. So when I say k is the last element, let me consider here input nums 10, 20, 30, 40, and k equals 4, it has to be, right? When k is the last element. So the output will be here. In this case, the output will be 10, right? So we are going with the when k is last element, nothing but k equals 4. This one, the fourth, this one, largest element in this case, it will be this one, 10. I hope this is clear. Let's move on with the final edge case, nothing but the final or the fourth edge case, nothing but negative numbers included. So this will be the fourth edge case. So here let me consider nums array -1, -2, -3 and -4. You can consider anything. In my case, I'll just consider this one. This is simple to understand, right? So k equals 2, if I give here, -2 will be the output. -1 will be, when k equals 1, it will be -1. When k equals 2, it will be -2 will be the output, right? So I hope all these edge cases are clear. The first one we discussed for the smallest input case. Second one we discussed for the all elements are same, when all elements are same. Third one, it was for the it was when k is the last element. And fourth one is for negative numbers, when negative numbers are included. So I hope all the edge cases are clear. Now let's start writing the code. So here, initially what we'll do, as discussed in the approach, let's create a max heap instance and initialize with the input array. So here, let's create the max heap first. So this one will be max heap, and we are initializing this one with the input array. In our case, this one, nums, right? So let's initialize this one with the input array nums. This is fine. Next step is we have to extract the max element k minus 1 times. This was the second step, right? That we had discussed. For that one, we have to have the, we need to build the max heap with the extract function or the extract method inside the max heap, right? So let's build the max heap. So here, class max heap, let me consider constructor which will be using for the initialization. Let me pass a within the constructor. I'll consider a as parameter here. Heap, let me use this one with the this keyword. We have to sort, we are sorting this one in the descending order. So we are sorting the array in the descending order to mimic a max heap. So just keep this one in mind. We are sorting the array in the descending order to mimic a max heap. This one will be a dot sort x comma y. This will be y minus x. This is fine, right? So next, let's go with the extract method or the extract function. So here, we have to extract the maximum element, nothing but first element in the sorted array. We have discussed this one already. So to extract the first element, we can go with the shift, right? We can just make use of the shift. I'll just give here return this dot heap dot shift here in this case, right? This is it for the max heap class, right? So next, what we have to do here, next step is here, second step was extract the maximum element k minus 1 times, if you remember. So for that one, I'll just write simple while loop here, minus minus k. This is fine. We have to extract this one k minus 1 times. So I'll just give here a decrement minus k, double minus k. This is fine. So we are extracting, right? So I have to write in this way, extract. So I hope this is fine. This is function, right? This is fine. The final step is the kth largest element is now at the top of the heap. We saw this one in the example as well as in the approach as well. So we discussed this one. So the kth largest element is now at the top of the heap. Extract and return the same thing. So here, simple heap dot extract. So here you can clearly see shift, we are making use of this one in the to extract the top element from the heap. So this will be heap dot extract. This is it. So this is simple, right? So they have asked us here, again I'm telling, can you solve it without sorting? Yeah, you can. You can just try this one without sorting as well. The code will be little lengthier. Or you can just go with the hash map as well, in my opinion. You can just solve this one with the hash map, or you can just go with the just max heap. I have just went with the max heap with sorting because n log n doesn't matter, man. For this problem, n log n is good for this problem. So I thought of solving this one by making use of sorting itself, right? So this is it for the problem. So let me hit the run. Let me format and hit the run. So what this is saying here, unexpected token extract. Oh, this one has to be heap.extract. So this is fine. Yeah, now you can clearly see all the sample test cases are getting passed here. So let me hit the submit button now. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct, right? So let's quickly discuss the time complexity and the space complexity of the code that we have written. So we know one thing here, the approach that we went with here is max heap or heap with the sort, heap with sorting, or you can just call it max heap sorting approach, right? So what will be the overall time complexity here in this case? The overall time complexity would be here big O of n log n. Why it is big of n log n? Because sorting plays the dominant factor here. Sorting is the dominant factor here. So the overall time complexity would be big O of n log n. Then what would be the space complexity here? Because it will be big O of 1. Why it is big O of 1? Because we are sorting in place, right? So we are just sorting in place. So that is the reason overall space complexity would be here big O of 1. I hope this is clear. The overall time complexity is big O of n log n, and the overall space complexity here is big O of 1. So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.